All right. Yeah, today's the second lesson on probability. Right. Remember, we call the definition of probability. This is going to be the number of the design outcomes over the number of the all possible outcomes. Okay. So if you know how to do counting, you shouldn't have no problems because you have to take with the numerator and denominator. Usually for the numerator, there is a additional condition restriction. Okay. And for the denominator, it will be much easier to say count all the possible outcomes using the principle of counting. Right, let's start with the following problem, and let's try and do one by one. Okay. Now, so we're going to do the following. Okay. A four-digit number is created using 4 digits, 1, 2, 3, 4, each ones. Okay, and what is the probability that the number is odd? Okay. A 4-digit number, okay, is created by using this 4 number 1, 2, 3, 4. Each ones, okay, only one. Okay, you cannot repeatedly use that 2, 2, 4, 4. Okay, what is the probability the number is odd? Okay. Well, let's do step by step. Okay, let's do the problem step. We have 4 numbers, right? And let's figure out the denominator. Denominator is all the number of all possible outcomes. So that means you have 4 digits, right? You just permutate them, right? One by one, right? So you get 4 factorial, right? Different numbers you can create. Okay. Now if maybe I modify the problem, but later. Okay, let's do this. Okay, so that's a 4 factorial. For the numerator, we should only consider even numbers. Even numbers means either the last digit is 2 or the largest digit is 4. Must be in this form. Okay. So you have 2 patterns here. So for the first one, right? There are a couple ways to do. You can work on the first one, then plus the second one. Okay, right? So for the first one, you have 3 digits here you can choose, right? 1, 3, and 4, right? So it's 4 digits. And here's a 1, 3, and 2. So each one is 3 factorial. Add them together, okay? Or you can choose a unit digit first. There's 2 choices. Then the rest of them you can randomly pick up. Okay, then you get 2 times 3 factorial. So the answer will be 1 over 2 after you simplify. Okay. Yeah, after you simplify, maybe 1 over 2. All right. Now, if I change the problem a little bit, okay, it's a 5-digit number. It created using 0, 1, 2, 3, 4. Okay, there is a 0 here. Okay, the 5-digit number, okay, is created by using 0, 1, 2, 3, 4, 1, 2, 3, 4, okay, and each ones. Okay, what is the probability that the number is odd? Or numbers? Yeah, what is the probability that the number is odd? Okay. All right, so this problem, I think some students maybe will make mistakes. All right. But if you carefully Okay, calculate the denominator, not numerator. It should be okay. Okay, so so I got. Anyone have answers right now? Yeah. Even the denominator, you have to be very careful. Yeah, the number of all possible outcomes. So you have 5 digits, okay? The first one on the left cannot be 0. This cannot be 0. So this cannot be 0. Be careful. Okay, this cannot be 0. That's my hint. Okay, anyone? Okay, so let's see. The denominator. How can I figure it out? Okay. I think the first first one. Okay, the first one on the left, you can choose any digits except for 1, 0. So it'll be 4 choices. Then for the second one, you have 4 digits left, right? So it's 4, 3, 2, and 1. Okay, so that is that's the denominator, the number of all possible outcomes. 5-digit numbers, the first digit is not 0. Now, in order to get an odd number, right? So this must be odd, right? This cannot be 0. Right, how to do that? Right? Yeah. So this cannot be odd. This is a lot. Unit digits must be odd. How many choices you have? Right? You have 2 choices. Odd, right? 1 and 3. 2 choices. That's 2. That's the first step. The second step, because you only deleted the 1 odd number, the 0 is still in the group, but cannot be 0. So 0 should be also removed when you determine the first digit. So there are 3 digits left, 3. Okay? Right? So 3 digits left. Not 3 factorial. Sorry. Okay. Okay. So we decide how many choices, right? So this is a factor, 2 factorial. The second step, you have to do this, right? So if you delete 1 digit, okay, from the group, it's odd digit. Then you have 4 digits left. Right? These 4 digits left, you cannot have 0. You cannot pick up a 0, so only 3 you can pick it up. So 3. Then you have the remaining ones, right? The remaining ones, you have 3, so you can choose any of them. So 3, 2, 1. Okay, 3 digits left for 3 boxes in the middle. Okay. So that's it. And then you cancel, right? So the answer will be 3/8. Got it? Yeah, awesome. Sounds is correct. Okay, you know how to do that, right? Step 1, step 2. Okay. Step 1, you have 2 choices. You choose, you fix the unit digit. Okay. For the last box, there was 2 choices. Then step 2, that's a step 1. You know, there's 3 steps here. 3 major steps. Step 1, step 2, and here in the middle, step 3. Okay. They choose 3 digits for the 3 boxes here. So then, and each step, right? So you get here, you get 3 factorial, right? Then you multiply them out. All right. Right, our next problem is, what is the probability of rolling a sum of 7 by tossing 2 fair dice? Okay, you're going to toss 2 fair dice. And you should get sum of 7. Okay, I want to try first. Okay, if you know how to do it, you can get the answer quicker. Yeah, I'm surprised. Austin always give me the right answer. Good. Okay, Angel, you did a good job. Okay, so let's try. Okay, so you have 2 numbers, right? Right, you will get 2 numbers. So this is so 2 numbers can be 1. Another number is also can be 6, right? So the sum is going to be 7. So 1 plus 6. Now, what kind of number? Okay, we count count in order. This is the first one, second one. So 1 plus 6 is 7, right? And then 2, maybe you get 2 plus 5, you get 7. Then 3 plus 4 equals 7, right? And the 4 plus 3 equals 7. And 5 plus 2 equals 7. 6 plus 1 equals 7. So total you have a 6. Right? The first one, second one. Yeah, it's in the order. We assume in the probability can always make some assumption. It's not like a group, right? So it's in this order. So the first one, you have 6 choices. The second one is also 6 choices, total 36 possible numbers you can get, but only 6 of them satisfying the required condition. Okay, so the answer would be 1 over 6. Okay, right? So you get for the first one you have 6 choices, right? 6 choices if without any restriction. For the second, you also have 6 choices. Okay, so total there will be 36 possible outcomes, but only 6 of them that meet the requirement. Okay, you can also look at the matrix. Okay, if you look at the matrix, the first number could be 1, second number is 1. The first number is 1, second number is 2. The first number is 1, the second number is 3. 1 and the 4. Okay, I don't have enough space, so let's erase this. Okay, so you can list all of them if you want. Okay, and then the last one will be 6 and 1. 6 and 2, 6 and 6. So total you have 36. Okay, 6 times 6, the 36 possible outcomes, and only those on the diagonal. Okay, only on those diagonal meets the requirement. Okay, and then that's just why 6 over 36. Okay. Right. Our next problem is as follows. You have 3 slips of paper labeled A, B, and C, okay? And they are drawn from a box, one at a time, without replacement. What is the probability that drawing A last? Oh, that's a question. Okay, so they're in the back. Okay, they're in the box. This is in the inside box. Okay, so this is yeah, 3 slips of paper. Okay, labeled. A, B, C. Okay. One at a time. Okay. So my question was without replacement. Okay. So what is the probability? The last one would be A. Okay. So you think 1/3? Andrew says also 1/3. Any different answers? Okay. So let's look at the box. Okay. So 3 numbers, you could put it one by one in the order, right? So the denominator clearly is going to be 3 factorial, right? The numerator, how do you figure out numerator? You want to make sure the last one is A, right? So the last one, this is for denominator. The last one is A. Then clearly, Crystal, you see, the last one is A. And so you don't have a choice. You only have a choice for the first one and second one. And then it's A, B, and C you can choose, right? So that means you only have a 2 factorial possible outcomes with a restriction. So the last one, okay? So that's why it's going to be 1/3 after you simplify. Okay, so A must be fixed, so M and B, C can choose for the first one or second one, 2 times 1, that's 2 factorial. Okay. And we modify the problem a little bit. And right now, this time you have 4 slips of paper, labeled A, B, C, D. Okay. Okay. Now this time, okay, my question is, yeah, it will be the same question, the same procedure. What is the probability of join A or B last? Now this time a little bit more complicated, okay? So the last one is either A or B, okay? The last one is either, not everybody can get the right answer for this one, okay? Also, you don't just think, you have to do the computation. You should know what is the numerator and denominator, okay? Yeah, maybe give us the original expression, then you simplify it to 1/3. Okay, so the denominator still is going to be 4 factorial because you have four letters you can permutate, right? You know, if you put a box here for the denominator, right, and the first one you have 4 choices, then 3 left, then 2 left, then just only 1, that goes to here, right? Okay. For the numerator, the last one, either A or B. So you have to pick one for the last one, right? So either A or B, so it's 2 factorial actually, right? 2 factorial because you can choose A or B. No, just two, not just 2, or not 2 factorial, just 2. Okay, it's the same number, but it's different meaning. So 2, you can choose one of those 2, so 2 choices. Then for remaining, then for the first one, because it's 1 is already gone, so you have a 3, then 2, and the 1. This is a 2. Okay, so that's why 3 factorial. The answer is 1/2. Okay, so this goes to here. Good job. Okay, now let's try a different one. Okay, so we are going to draw 3 this time. Okay, 3 letters. Okay, 1 by 1 without replacement. Okay, so you have A, B, C, D, E, F, G. Okay, you have this many. So what my question is, what is probability that the third one is A? Okay, so the third one is A. Now you can also, draw 5 letters out of 7, right? Right? What is the answer? I'll give you a half minute to think about it. Right. Oh, I got couple answers. Wow. Someone get 1/49. Some get 1/7. Some get 1/42. So we do have many different answers. Angel even got much smaller number. So what is Austin's answer? What's your answer? It's covered. I have to look at. We are still trying. Okay. All right. So let's see. The denominator. You know how to pick up 3 letters, right? Out of 7. Right, out of 7. So you have a 3. Right, you pick up 1 by 1. So the first one you have 7 choices. Second one you have without any restriction, right? 6 choices and 5 choices. So this is a product that gives the number of all possible outcomes. Okay, now it's clear, I think, Kevin, right? So the third one must be A. So that this is for the, you have a 7, 6, 5 choice for the denominator. And for the numerator, the third one must be A. No, right? No, it's a fixed. Okay, there's only 1 letter here, so it's no choice. You just put A there. Okay. Then for the first one, right? For the first one, you have 6 choices because A is gone, right? That's only 6 letters left. then the second 5 choices, 6 and 5. So the answer is 1 over 7. That's it. Okay. Yeah, there are 7 letters there. All right, so our next problem is there are 2 girls, 3 boys in a class. What is the probability that students at the end are both boys? So they're sitting in a row, okay? 5 students sitting in a row, okay? 5 students sit in a row, okay? Okay, so 3 boys there. 3 boys, 2 girls, okay? And my question is, what is the probability that students at the end are both boys? Right. So this is a, boy, right? And the second, we don't care about the second one and the third one, the fourth one. I want to make sure the boy, you arrange the seats for 5 students. That's 2 boys, 3 boys and 2 girls. I want to make sure 2 boys sit at the 2 ends. Okay. All right. So now we have 2 different answers. Okay. The denominator is clear, right? Why? Because you have 5 seats here for 5 students. The first one, let's put the 5 seats for this is for the numerator when I do that. Okay. For the denominator, have 5 seats, right? So 5, 4, 3, 2, 1. So it's 5 factorial. Right? That's the denominator. Clear? For the numerator, what we have to do? How to guarantee the students at 2 ends are boys, right? So you have to choose the boys first for this seat, for that seat, right? For the end on the left, for the end at the right. Okay. So I'll give you 1 more minute, a little bit more time to correct the answers. So far, I haven't seen a right answer yet. Maxwell, you're almost there. All right, so let's do this. So for the seat, for the first seat, right? You only choose the boys. There are 3 choices. For the second, for the last seat, you still have to choose a boy. So there will be 2 choices. Okay. Then for the 3 seats in the middle, you have 3 students left. Then you have 3 factorial choices, right? So your answer will be 3, 2, 3 factorial, 5, 4, and 3 factorial. So cancel it out, and you get 3 over 10. Yeah, 3 over 10. That's it, Okay, another question is the same problem. What is probability that boys and girls sit alternatively. Okay. Now what that means there's two patterns here. Boy, girl, boy, girl, boy. Okay, I don't think that's as a possible pattern because only two girls there. Okay, must be sitting in this order. Right? You cannot, yeah, if I have 3 boys, 3 girls, then the problem will be more complicated. But for the 3 boys, 2 girls, this is the only possible pattern. Girl must be sitting inside. Okay, so then what is the answer for this problem? All right. Okay, Maxwell, you need to do the problem more carefully. Yeah, you got some strange numbers here, 1 over 25. Right, so the probability, right, the denominator, 5 students, you can randomly put them in the high 5 seats. That's a 5 factorial. No question about that. The question is, how do you choose 3 boys, 3 girls? How do you choose 3 boys, 3 girls? So those are the seats already fixed. Those are the seats, the third one, the first one, and the last one will be for the boys. So you pick up 3 boys, put them in this order, in these places. So there will be 3 factorial choices because there's 3 boys. Then you pick up 2 girls for the 2 seats between them. So that's 2 factorial, many. Okay, so the answer will be 1 over 10. Okay, it's 1 over 10. So that's why it's after simplifying, just 1 over 10. Okay. Okay. A similar problem. Okay, we have 5 students. Okay, 5 students. We don't arranged. Okay. I have a question here. The question is, so if 5 students, Aaron and David, are among the 3 boys. Okay. So those 5 students are sitting in a row. Okay, 5 students will be seated in a row. Okay. And Aaron and David are among them, among the 3 boys. Probably doesn't matter there. Maybe among the 5 students. Okay. What is the probability Aaron and David sit next to each other? Okay. I just among them. Okay. I don't need to say 3 boys because it's not necessary to know the genders. Okay, 5 students will be sitting in a row, and if Aaron and David are among them, what is the probability that they are sit next to each other? That means Aaron and David. All right. All right. So there are 5 seats here, right? 1, 2, 3, 4, 5. Okay. How do you how do you how do you figure out the pattern? Okay, how do you figure out pattern? Okay, so all that matters, right? So there are two possible patterns. Pattern one, A and D. Okay, A means Alan, D means David, and in this order. Another pattern is D and A. Alan is on the left, David is on the left, Alan is on the right hand side. The two possible patterns. Okay. So for each pattern, right? So you can have how many choices, right? For the Alan first, David second will be AD star 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 AD star, right? And the star star AD star, then star 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 AD. Okay. So this is a possible arrangement if L is on the left. Okay. So the denominator is always a 5 factorial. The numerator, I just need to figure out the first one. Okay. Figure out this. Okay. First of all, you choose a seats for L and David. How many choices? For L and David. For L and David, there are 4 choices. Okay, first step. Okay, so this is how do we do that? Okay, you choose a pair of seats for Alan. Okay, step 1, and then choose a pair of seats for Aaron and David. Okay, so they're next to each other. Okay, this pair of seats are next to each other. So then you have 4 pairs of seats you can choose, because one pair, another pair, another pair, another pair. Okay, 4 pairs. Once you choose a pair of seats, then you have to let Aaron sit first or second, doesn't matter, right? So there's 2 factorial many choices. Okay, for Aaron, that's a step 2. Okay, assign seats. For Aaron and David. So this is a 4 choices and had 2 factorial, because once you have 2 seats, either Aaron or David, okay, or David and Aaron, right? Step 3, assign seats for the remaining students. There will be 3 factorial, because 3 seats left and 3 students left. Okay, yeah. Assign seats for the remaining 3 students. Okay, that'll be 3 factorial. Okay, that's why after simplifying, it's going to be 2 over 5, not the 1 over 5. It's 2 over 5. Okay, why it's 2 over 5? Because the numerator is 2 times 4 times 3 times 2 times 1. The denominator is 5 times 4 times 3 times 2 times 1. Right? Cancel out. That's 2 over 5. Right, and a little bit more challenging problems. I have 3 girls and 3 boys. Okay, they are seated in a row. Okay, what is the probability that girls on the same side? Okay, you have 2 sides here. This is the middle. Okay, and I have 3 seats here, 3 seats. You know, they're put in a row, but there's a middle in there. Okay, so what is the probability that 3 girls on the same side? Okay. All right, so the probability for the denominator, okay, the denominator is 6 factorial. The only problem is how to make arrangements for the girls, okay, and for the boys. Okay, don't do so fast. Okay, you think about the possible ways to assign the seats. So that 3 boys on the left, 3 girls on the right, or 3 boys on the left, and 3 girls on the right. Okay, so there, my hint is here you have boys, you have girls, or it's the girls and boys. Okay, that's my hint. Okay, so you think about that, and I'm going to write down the next problem. Okay. All right, let's finish the first one, okay? So there are 2 patterns, okay? So in order to, you assign the seats for 3 boys on the left, you have 3 choices, right? 3 factorial many choices. Okay, so how do you solve this problem, right? You have first of all, yeah, okay, how do you do this? You can try this way. Okay, let's do this. Okay, do one more step. Okay, you have either choose which side for the boy, which side for the girl. That's two choices for the first step. Decide which side is for the boy, which side for the girl. There's 2 sides here, so it's 2 factorial many possible. Then once you fixed, if a boy's on the left or the girl's on the right, then you work on the boys, right? And there's 3 boys there, so you have 3 seats for the boys, so 3 factorial many choices, right? Then third step, you choose the seats for the girls. There's 3 girls, so 3 factorial many choices. Okay, so total will be this. Then you simplify it, right? It's let's say 2, 3 factorial, 6 is 6 times 5 times 4 and 3 factorial. So 3 factorial cancel out, and 3 factorial and 6 is canceled out, and that's why you get 1/10. All right, finally, 1/10. It's a 1/10. All right, so now let's look at the next problem. So 6 students are seated to be seated in 2 rows. So we have this side and that side, left and the right. Okay, left and right. I have 3 seats here, 3 seats here, and we randomly put them in 6 students in a row. But Andrew and Mike, okay, are among them. So it's possible Andrew and Mike are on the same side. So what is the probability that Andrew and Mike will be on the same side? Right? So the question is, how do you assign the seats? Right. So now we get all kind of different answers here. So let me explain to you. So the denominator, is clear, right? It's going to 6 factorial. So question, how do you fix how do you assign the seats? If you're a teacher, right, you want to put, right now you want to make sure randomly you can, under condition, right, randomly assign the seats to 6 students, but you want to make sure Aaron, and make sure Andrew and Mike will be on the same side. What do? I let Andrew to select the seat first. Then Andrew said, look at the 6 seats. He can pick up any of them, right? Okay, Andrew already sit down, but he has 6 choices. That's a step 1. Then once Alan chooses a seat, it could be on the left, it could be on the right. Then you call Michael. Michael, come on, right? So you pick up a seat, but must be on the same side as Andrew. So only 2 seats left for Michael to choose. So Mike said, okay, I only have 2, so it's 2 choices. Then I have 4 seats left for 4 students, and doesn't matter how do you put them, right? So that can, then 4 seats for 4 students, that'd be 4 factorial. Got it? That is how do we calculate. So then you simplify it. You get 6 to 4 factorial, and here's a 6, 5, 4 factorial, and 4 factorial cancel out. This cancel out. The answer is 2/5. All right. Yeah, you need to design as a way, what is the first step or the second step to assign the seats. So guarantee Andrew and Mike will be on the same side. So you can choose Michael, okay? You can call Michael first. Michael select seats first. Then there are 6 seats there, Michael. Okay, I could choose one of them and then sit down. So Michael has 6 choices. Then Andrew select a seat. When Andrew must go to the same side, there's only 2 seats left, so Andrew choose 2. Right? It's pretty clear, right? Then for the remaining 4 students that come in, and then 4 seats one by one, they choose. Right? The third student can freely choose one of the 4 seats. So it's a 4, right? Then then one by one, the number decrease. So you get 4 factorial. Right? Right. Our next problem is D is selected at random from all the group of all the digits. Okay. What is probability that the 4-digit number 232D, okay, is divisible by 4? Okay. Now a 4-digit number divided by 4. How do you determine a digit number divided by 4? Right. So how do you check a number is divisible by 4? It's a little bit hard, but we know the factor. Okay, we know the fact 100 is divisible by 4, right? So this is a clear. Okay, so we use this fact, simplify the problem. So this is a 2,300. So don't worry about that. It's divisible by 4. Then have a 2D, right? Okay, then it's clear. So this number is divisible by 4. This is divisible by 4. Divisible by 4. So 2D is divisible by 4. If only have 2D is divisible by 4. Right? This should be divisible by 4. Okay. Now 20 something divisible by 4. There are not many choices, right? So the D could be 24, right? Then 8, right? And D also could be 0. Yeah, 20 is divisible by 4. So that's it. So those are the possible digits for the value of D. So the answer is, the probability is total you have 10 choices for the denominator. The numerator there are 3 choices. So it's 3 of 10. 3 over 10. Okay, 3 over 10. That is the answer. Okay. Okay, let's go back to review some problems we did. Okay. All right, let's do this problem. Okay, 3 boys and 3 girls are seated in a row. Okay. What is the probability that boys and girls are sit alternately? Okay. All right, so you have to figure out possible patterns for this problem. Okay. Right, the possible pattern, you think about boy first, right? Then G and then boy, and G, boy. Good. Or another possible pattern is G first, right? Okay. Now, I always get different answers. No. So Austin gave me 2 different answers. So what is probability he gets the right answer? 1 over 2, right? That's right. All right, so what is the answer, right? So denominator, let's figure out the denominator. The base is a numerator, it's the most important thing. So you have to figure out the total number of outcomes in the first pattern, then multiply by 2, or add them together, right? So there are 3 seats here, B, 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 and G, G, G. So we already fixed that. Those are seats for the boy, those are seats for the girls, right? So for the boys, you have the 3 factorial many choices. Step 1, select the boys. Arrange the seats for the boys, the 3 factorial. And then arrange the seats for the girls, the 3 factorial, step 2. And then the right-hand side the same. Okay, if the girls first, the boy second. So the denominator is going to be 6 factorial. Okay, so the answer will be 2, 6 factorial, 3 factorial. 6 factorial is a 6, 5, 4, 3 factorial, cancel. Okay, so I get 1 over 10. I got 1 over 10. Okay, let's try another one. Okay. Okay, randomly, write down 2-digit number. Okay. What is the probability that the number is divisible by 3? right? What is the probability that the number divided by 3? Yeah, write down the number at random, right? Of course, at random. You let the machine to generate a 2-digit number, right? What is the probability that the number is divided by 3? This is a problem quite different from the previous one. We have to do the calculation. So 1/10 again. First of all, yeah, look at those numbers, right? It's going to be a 2-digit number. It's going to be 10, 11, blah, 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 99, okay? Okay. So a number is divided by 3. Let's look at how many numbers are divided by 3. So 3 times p should be less than or equal to 99, greater than or equal to 10, okay? So you do the calculation, okay? P is going to be 33 here, greater than or equal to 3 point something, right? Right, 10 divided by 3 is a 3 point something. So the number of choices for the P is going to be 4, 5, all the way to 33, okay? So how many choices here? Actually, it's going to be 30, right? So the probability is you have to figure out the total number of 2-digit numbers. Total number of 2-digit numbers here is 90. Then 90, right? So then 90, 2-digit numbers there. So those who are divisible by 3, there will be from 4 to 33, right? So 33 minus 3, that'll be 30. So the answer is 1/3. Okay, there'll be 1/3. Okay, there will be 1/3. Yes, right? Now, if I modify as a problem, yeah, can you do that? What is the probability that one of the digit is 3? Yeah, that will be slightly different, right? So the denominator is still 90. The question is, how do you count? Remember, we did a similar problem. How do we count the number of digits containing 3? Okay, one of the digits. Okay, so from 10 to 19, there's only one number containing digits, right? Right, and from 20 to 29, that's only one. But from 30 to 39, and there are first of all 10 digits plus, right? All of them contains 3. All of them contain 3. Okay, I'm not counting the number of digits, right? I just say those are digits always contain 3. Then 40 to 49, it's 1. 50 to 59, 1. 60 to 69, 1, right? And then let's list 10, 70 to 79, 1. 80 to 89, 1, right? 90 to 91, 99, it's also 1. So 1, 2, 3, 4, 5, 6, 7, 8, 18 or 17? Question. Question. Okay. Right? In each group, there was 3 there. Okay. So this will be, no, I just say contains one of the digits of 3, not exactly one digit 3. So 18 should be the answer. Okay. So read the question here. One of the digits is 3. So 33 is still counted. Okay. Okay. Bye-bye.